All right, everyone. So let's go ahead and get started. So this is our first lecture of the semester. So as you see here, the first thing we're going to do this semester is talk about some fractions. Okay, so it's very important to understand the rules and the properties of fractions. We're going to be using them for multiple topics throughout this semester. First, I would like to start with a simple definition. Okay, using my new fancy pen here. I have a little tablet that I'm using right now. It's still a little, what should I say? It's a little squeamish, but I'm getting used to it. So the writing may look a little weird or a little awkward, but I'm using this digital pen on this tablet. Okay, so I want to define ways when we start any topic. I'd like to start by defining it, or define what fractions are and their components, and later you will learn how to simplify them, multiply, and also divide fractions. So as you know, a fraction, the meaning for the word fraction, it means portion or a piece of something. That's the definition of fraction. So if you have a piece of something, if you have a whole piece of whatever it is, and I said, give me a fraction of it, that means I want to get a piece, small piece from the whole, or a fraction. The simplest one would be the infamous pizza or pie example. Let's say you wanted to get a fraction of this pizza, maybe a quarter or a half. Let's say I wanted to get one slice. I want to get 1/4 or 1/4 out of this pizza. First, I need to divide it into 4 equal pieces and then take however many pieces I want to. For example, in this case, 1. So 1/4 or 1/4. 1. And also say 1. 1/4 like this. And of course, once you divide your thing into 4 equal pieces, you just take one piece out of everything. So 1/4 represents this. Okay, what's the non-shaded fraction of this pie? The non-shaded. What is the fraction that represent that? If 1/4 is the shaded, okay, what's the fraction of the non-shaded portions here? What out of what? It's another fraction like this, but will be 1, 2, 3 portions out of 4. So 1/4 is shaded, 3/4 is not shaded. Okay, so that's a fraction. That's also a fraction. So again, the concept here is fractions are just it just means a piece of a whole, and we represent that by 2 numbers. Oops. Okay. Now let's look at another example when we shade. When we shade a specific part of something. Let me just open this thing here, this book real quick. Okay, so give you an example of, let's say I have this whole piece, right? One whole, could be anything, could be bread, could be a stick, could be anything. So in this example, we had to do, we had to shade 1/4 of this, 1/4. Okay, but this one, let's say you want to shade 2/5. or 2/5. Okay, so give you one whole piece, and I wanna get 2/5 out of that, or I wanna shade 2/5. So how do you go about that? What's the first thing you do here in order to get this exact fraction from this shape, from this whole shape? What do you guys think? What do you do first in order to get 2 out of 5 from this whole piece? We welcome your suggestions and your...
Divided 5.
Exactly, so we're going to divide it first into this, 2 5. So 5 equal parts. Okay, you want to be fair. So 1, 2, 3. Let's assume these are equal 1, 2, 3, 4, 5. So you want 2 out of 5. So first we're going to divide those, and then we're going to get any two pieces, because they're equal. It doesn't matter which ones you pick. Unless you cut in bread, for example, then you may want to go from one to the next direct consecutive piece. Okay, so that's shaded, right? What is the fraction of the non-shaded? So 2 out of 5 is shaded.
3 divided by 5.
3 out of 2.
Exactly. 3 out of 5, 3 divided by 5, or you can say 3/5. In fraction terms, we say 3/5. And so on. Okay, so basically that's how fractions work. You just small piece out of a whole. Now let's see what each fraction always is made up of two things. You have a number over a number, which is the same as saying A by B or A divided by B. All these notations are pretty much the same. We say A over B, A by B, A divided by B, or you can also say A out of B. This probably makes more sense because we take something out of something. So each one of those numbers has a name. What do we call A? What do we call B? These two numbers have specific names when they are in a fraction. What do we call the top and what do we call the bottom of a fraction? At least we're all familiar with the bottom one. What do we call the bottom of a fraction? Starts with a D.
Denominator.
Right? The denominator. What about the top? Top here is called, starts with an N, B, numerator. Numerator. Okay, so these are the components of a fraction. A over B. A is a numerator, or the B is a denominator. But to simplify things, we'll probably just be calling them top and bottom. Top and bottom. It's easy to say, easy to write. But that's the actual nomenclature of those numbers. What else? So now we're going to see another form, or another thing we can do with numbers, which we call factoring. Factoring is very simple. It just means breaking down numbers into multiplications. For example, 15, we can write this as a multiplication of what? 15, if we're written as a multiplication, what would that be? Multiplication of two numbers. 5 and 3. Just factored it. Okay? That's what factoring means. We rewrite a number into a product of its factors. So 5 and 3 are factors of 15. Same thing with 18. You can say it's 9 times 2, which is also, if you break down the 9, that's 3 times 3 times 2. So these are called prime factors. Of, let me rewrite that. Call those prime factors of 18. So basically, it just means you break down a number into multiplications, and you keep breaking it down until you can't break them down anymore. So the numbers that you get at the end are called prime factors. Why? Because we can't break them down anymore. Okay, so that's basically the meaning of factoring here when we factor a number. Let's take another example. Maybe 24. Usually, I use a tree form to do this factoring. It probably makes more sense when you do it like a tree. So first you start by breaking down this whatever number into any two numbers first, any two numbers, and then you keep going down as far as you can. So what is the, well, give me two numbers I'll multiply to 24. Any two numbers. Two numbers I'll multiply to 24, everybody. For example, 8 and 3, right? 24 is 8 and 3. Then, so we can break these down. Can we break down the 3?
No.
We can. That's right, because it's a prime. It's a prime number. Okay, prime number can't be broken down. It can only be itself. It can be divided by 1 basically. But we can break down the 8 into 4 and 2, right? 4 times 2. Then, actually, let me use a tree for that as well. I can say 4 and 2. This can be broken down more into 2 and 2. Break these, or bring these 2 down. You can't break it down anymore, and bring the other 3 down. Can we break down any of these numbers anymore?
No.
We can. So what do we call these numbers again?
Prime factors.
Exactly. Call them prime factors. So these are the prime factors of the number 24. Okay, that's what factoring is. Very simple, just breaking down the numbers until you can't divide anymore. So prime numbers are the numbers you can't divide or you can't break down. They start actually from they start from 2, not from 1, but 2, 3, 5. What's the next prime number after 5? A number you can't break down, you can't divide is?
7.
Exactly, 7. And 8. Is 8 prime or not prime? As we saw here, 8 is not prime because we can break it down into two numbers. So 8 is not prime. Move on to 9 is not prime. 10 is not prime. 11 is prime because you can't divide it. And so on. If a number is not prime, what is it? What is the opposite of prime? Call that composite. Composite numbers. Basically, the numbers that are not here are composite. The numbers you can break down, for example, 4, 6, 8, 9, 10. See these? You can break them down. For example, you can divide this by 2, you can divide it by 4. Here also you can divide by 3, or by 2, or by 6. So these are composite. So we have prime numbers, and we have composite numbers. Okay, so prime numbers can only be divided by themselves and 1, not including the 1 here. The 1 is not included. But composite numbers, usually, we can break them down into 2 or more numbers. Okay, that's basically factoring. Very simple. You just break down the numbers. So the reason why we learned this factoring is to use it to simplify fractions. That's our next section, simplifying fractions. So when you have a fraction like this, let's say 15 over 5, we'll always look to make our fractions as simple as possible. If you look at this fraction here, 15 over 35, do you think we can simplify that fraction? Is there any way to make that fraction simpler? So to do so, that's when we need factoring. So we're going to factor this top. Okay, so we're going to factor the top, which will be 5 times 3. And also factor the bottom here. What is the, give me two numbers that multiply to 35. Just mute yourself if you have background noise. James, I believe. Okay, so 15 is 5 times 3. What is, give me two numbers that multiply to 35.
7 and 5.
That's right, 7 and 5. So once we factor both the top and the bottom, it's like so. You may have two numbers here, or you may have more like this. Then you want to cancel the common ones. So you cancel this and this. 5 and 5 cancel each other. You end up with 3 over 7. So this fraction is the same as this one. I mean, they're equivalent. Okay, but this one is simplified. So these are equivalent. It's still the same ratio. Okay, same ratio. 15 divided by 35 is exactly the same as 3 divided by 7. But this one is simple because we simplified it. That's what we mean by simplified fractions. So whenever you deal with fractions, you want your answer to be as simple as possible. And also, even before doing anything with fractions, let's say adding, multiplying, dividing, you want to make them as simple as possible, because this makes simple fractions make any operations with them easy and fast. Let's do another one. Okay, 21 over 28. Can we reduce or simplify the fraction? Another expression for simplifying is when we say reduce to lowest terms. Okay, let me rewrite that. We say reduce to lowest. Okay, so they are the same. So the question may say simplify, or may say reduce to the lowest terms. It means the same thing. As always, so to reduce a fraction, you want to factor both the top and bottom. So what number is multiplied to 21? Let's factor. Okay, let's factor like this. Factor 21, that would be. Two numbers that multiply to 21 are 7 and?
7 and 3.
That's right. And for 28?
7 and 4.
That's right, 7 and 4. Once you factor, then you cancel any common factors. So what's the common factor here? Common factor between the top and bottom is the 7. So if we cancel that 7 out, we end up with just 3 out of 4. As you can see, that's a simpler fraction compared to this one, but they're still the same equivalent fractions. Let's do a bigger problem now. Let's say you have, let's say 140, and we have maybe 210 here. Same way here. Let's see if we can reduce this as much as possible and make it a nicer, simpler fraction. What do you think happens first here in order to reduce this fraction? What do you think you want to do first?
See what numbers go into 140 and 210.
That's right. Or there's one obvious thing we can do quickly right away. What do you think that is? There's one thing we can do quickly, and then we'll repeat. We'll do something like this. The zeros. What do you think happens to the zeros?
So you cancel out the zeros to make it simpler as a number as 14 over 21, which those both numbers would have 7, so it would equal out to 2 out of thirds, basically. 2/3, sorry.
Exactly. So always, if you have zeros, cancel them. As many zeros from the top and the bottom. If you have 2 here, you cancel them again 2. If you have 2 here and 1, you can only do 1 against 1, 1 against 1. So you cancel those, you get 21. If you look at 14 and 7, they have something in common. I mean, 14 and 21, they have 7 in common. So we say, we can say here, 14 is 7 times 2. Let me see if my pen is acting up. And then 21 is 7 times 3. And of course, cancel the common ones, you get 2/3. So 140 over 210 is the same ratio as 2 over 3, but this is much simpler. So let's say you want to get 2/3 of something. It's much easier to say, I want 2/3 of that, instead of saying I want 140 over 210 of something. Let's say you have an object like this. We want to get 140 out of 210 of it. First, we simplified it into this. Now, how do you get 2/3 again out of this? What do you do first?
Divided in 3.
That's right, we're going to divide it into 3. And how many pieces do we take?
2.
2. Okay, divide into this and then take 2. So that's 2/3. And see the convenience of having a fraction simplified. Okay, if it was this, you don't want to divide this into 210 pieces and then count 140 pieces. That seems hectic and repetitive, but in math we'll always try to make life easier, find the easiest or the shortcuts or the simplest methods to solve problems. That's basically how you simplify fractions. Sometimes you don't have to do this. Some of you are probably a lot more advanced than this method here. This is the breakdown of it, but you could possibly skip some steps. For example, say you have some like this, 25 and let's say 45. Pretty sure you can already see what's common between these two, and we can divide that right away and write the solutions. So for example, what do you think is common? What goes into both 25 and 45?
5.
That's right, 5. So usually you can do this faster. You can do it this way if you feel comfortable, or you can just look at them and say, oh, 5 goes into this. How many times does 5 go into 25?
5.
5 times. How many times does 5 go into 45?
7. No.
Not quite.
9.
Okay, that's 9. And then you say 5 over 9. This is the faster way. If you don't do it, that's fine. If you're not sure, if you're skeptical about it, feel free, take your time to break it down like this. Even if you had to do this, break it down as much as possible, and then cancel the common ones between the top and bottom. The more you do this, of course, the more you get used to it. And once you get used to it, you start doing it fast in your head like this. Let's see now. So the simplifying fraction reduces those terms. The next section is, let's say, we're going to see how to deal with something like this. Before I tell you what it is, see if you can figure it out. What do you call something like this? What do you call a number like this?
A whole number?
It has a whole number and it also has a fraction next to it. What does the whole thing make? It's a mix of two different numbers, so we call it a mixed number. Okay, this is a mixed number. not just a fraction, it's a fraction with a whole number next to it. So let's see how to convert fractions or improper fractions into mixed numbers. Okay, so we have two types of fractions. Two types. Fractions depending on which number is higher. If you have a over b, if a is higher than b, what type of fraction is it? If the number here at the top is larger than the number on the bottom of the fraction, what is the name of this fraction? What type is it? Is it proper or improper?
Improper?
That's right. Okay, and the opposite, of course, is when we have,
Proper.
that's right, when a, should say here a, less than b. When the number here is smaller, just like 5 over 9, the fraction is called proper. Proper. Okay, example here, 7 over 3, 11 over 5. And here example would be 2 over, say, 7, and 9 over, let's say, 12 or 17. Okay, keep that in mind. So whenever you have a mixed number like these, we can turn that into, or whenever you have an improper fraction, we can turn that into a mixed number. So these can be turned into mixed numbers, not these. If the fraction is proper, then we can't turn it into a mixed number. Let's see how to do that. Let's start with this one, 7 over 3. Seven over 3, you can write this as a mixed number with a whole part and a fraction part. It's very simple. You just say, does anybody know how to turn this into a mixed number before I show you how? 7 over 3.
It would be it would be two
Okay,
wholes and 1/3.
exactly. 2 whole and 1/3.
Because three would go into 7 twice technically, and you have 1/3 left over if I'm not wrong.
Exactly. So 7 over 3. So 3 goes into 7 twice. That's the whole part. If 3 goes into 7 twice, that's 6. So the leftover, or the remainder, is 1. And the denominator stays the same. So if you do this in the division form, so 7 divided by 3. So the top number of a fraction always goes inside. And here we have the divider or the divisor. So we say 3 into 7, that's twice. 2 times 3, that's 6. We subtract, we have 1 left. So this is what we call the remainder. And the number here at the bottom, we called it earlier the numerator, and this is the denominator. But when we set up the division, this is the divisor, or the divider, and what we call the number that we divide. For example, 7 here. So if this is a divisor, what do we call 7? Because it's derived from this. What do you think that number is? So this is a divisor, we call this a dividend. Okay, dividend. Finally, does anybody know what we call 2? When you divide something by something, let's say 15 by 3 is 5. what do we call this result? The result of the division. It starts with a Q. Anybody want to take a guess? Any ideas? That's called the quotient. Okay, the dividend, the divisor or the divider, and the quotient. So 2 here is Q. Okay, so that's basically how you set up how you turn mixed numbers into, or improper fraction into mixed numbers. You can do it right away if you're familiar with it. If not, think of it as a division. So we're dividing 3 into 7, 3 into 7. Okay, the quotient here is the whole, is what goes here. Okay, so the quotient of 2 is this number, of course, and the 3, of course, is what's here. And this number here that's left, the 1 is what goes on top of this fraction, and this denominator stays the same. Okay, so 3 into 7, that's twice. Bring over the same denominator, always stay the same. Basically, this is what's left from this division, or the remainder, like this. That's the number that goes here. So we say 2 and 1/3. So this number is 2 . This mixed number here, 2 and 1/3. 2 and 1/3. Let's do another example. Let's do this one here. By the way, again, you don't have to do this division unless you have to, unless you need to. If you can't see the numbers, feel free to use a division. Or you can just write the solution right away. So 11 and 5. Okay, can you guys turn this into a mixed number quickly, right away, without doing the division? 11 over 5. So again, what is the whole part? Or,
2.
in other words, how many times does 5 go into?
2 wholes.
2 wholes, that's right.
2 wholes over 1/5.
That's right, 1/5. So we bring over the same number here. It's always going to be the same. And this is a remainder. So if you divide, or 5 goes into 11 twice, which is 10. If you subtract 10 from this, you'll get 1. So you start your fraction a little bit here in the middle of the number, not the base of the number. So it's 2. So we start the mixed number with the fractional right in the middle here of the 2, not the bottom of it. If you put it on the bottom of the number, this term looks like a multiplication of 2 and a fraction, but you want to put the number here somewhere in the middle of the number, the fraction. Okay, so put that over here. If sometimes you may have to do the division if the numbers are in not as convenient or not as small as these, so you may want to do your division to find the actual mixed number. Let's look at probably another number. So let's say 13 or this over 12. So this is quite an interesting number. It's not as easy as this one. So this you may have to actually do the division. So what is the mixed number? So we have to do the division like this. So let's set it up. Okay, so you do the division. So what goes inside here again? Which one of these goes inside? Everybody?
131.
131. So the top always goes inside. Even if it's smaller, it doesn't matter. The top of a fraction goes inside. The 12 goes outside here. Now we're going to do 12 into 131. So instead of doing 12 into the whole 131, we're going to attempt to see if 12 goes into these 2 digits first. Does it?
Yeah, 1.
That's right. So it's easier if you attempt 2 digits from here and 2. See if it goes into it. If not, then you can consider the 3 digits. In this case, 12 goes into 31. How many times? I mean, 13, not 31. 12 into 31, that's
1.
1 time. We times 1 by 12. Bring that over here. 1 second. So if we subtract, so 13 take away 12 would be 1. We still have this one hanging in there. So we're going to have to bring that down here. This one here. So this one comes from the subtraction of the two, but this one, part of the number, we're going to break it down. So this turns into another one here. Okay, so 12 into 131. How many times? So we have 12 into 31, which is once. We brought this down. Okay, so how many times does 12 go into 11? How many times specifically in math? How many times does 12 go into 11?
None.
None. In math, that means?
It's negative. Right?
No,
No.
not even once. So how many times is that in math? What's the number?
0.
Exactly, it's 0. Okay, so that's basically it. So we have 12 into 131, that's 10 times, and we have something left. So that's division. Now give me the setup here of the mixed number. Look at the previous examples, you can look at them. Now give me the mixed number of this improper fraction. What is it?
10.
10. Okay, a letter fraction, and
11 over 12.
exactly, 11 over 12. Again, this denominator always stays the same. This is a remainder. What's left, that's what goes here. Okay, so depending on the situation, if the numbers are small, you can do this. If the numbers are a little bigger, feel free to do your division and write your mixed number.
Quick question. So the remainder always goes on top of the fraction, right?
That's right. That's right. And the
Okay, I got you.
denominator remains the same. Okay, so that's basically how you convert fractions. Convert fractions into mixed numbers. Now we're going to do the opposite of this. We're going to start from mixed numbers and go back to fractions. Okay, so converting, let's call this, could call this number 5. So mixed numbers. Do fractions. The opposite is pretty simple as well. So let's take this very example and work with it. So here we took 7 over 3, we turned it into 2 and 1/3. So let's do the opposite now. We're going to take this mixed numbers and go back to its form of an improper fraction. So 2 and 1/3. And let's turn that, so we have 2, actually 2 and 1/3 like this. We want to turn this into a fraction, basically this fraction here. So how do you do that? What do you do with these numbers in order to get that mixed number here, or that improper fraction? First, if you notice, the denominator stays the same. So 3 here remains 3. So whether you're going from mixed to fraction or the other way, remember that the denominator remains the same. Now we just need to figure out how to find this number, which we already know is here, but how do you get that 7 from these numbers? You have to do some multiplication and some addition with these numbers. What exactly do you do to get this numerator? Any ideas, everybody? So here we divided Here we need to do the opposite of division. What is the opposite of division?
3 times 2 plus 1.
Exactly. We're going to multiply these two and add this. So 2 times 3 plus 1. So you times these two and you add the, it's supposed to be the remainder. So it turns into 2 times 3 is at 6 plus 1, 7 over 3. That's how you get back from this to this. Okay, so again, if you want to go from here to here, you divide 3 into 7 to get 2 1/3. If you want to go back, just keep the 3 the same, times these two, 2 times 3, and add the remainder here. That number that goes here, which is the remainder. Let's do that with 2 1/5. We want to turn this into this quickly. So again, what goes at the top, or how do you get the top?
Five times 2 plus 1.
That's right, 2 times 5. Over, of course, again, this stays the same. That's 11 over 5. And that's the number we talked about here earlier. So it's pretty simple to switch back and forth between mixed numbers and improper fractions. We need that when we add and subtract, multiply and divide, as we're going to see in the next few examples. Now, we're going to see how to multiply and divide fractions. Number 6. Multiplication and division of fractions. Okay, so I'll start with a very simple example here. You have 2 over 3 times 1/5. How do you multiply fractions?
Find a common denominator.
Well, we don't need a common denominator for multiplication and division. No common denominator is needed. We just need to understand which way to multiply. So which way to multiply these in order to...
Straight across.
Say it again?
Straight across.
Straight across. Very good. If you guys can get closer to your microphones so we can hear you clearly. This is also being recorded for you for later to view. So please get closer to your microphones and speak up a little bit. You guys hear me okay, right?
Yes.
Okay. So multiplying fractions is straight across. Straight across. Not cross multiply. Forget about cross multiplying. We're not going to do that in this class. Everything is straight across. So this turns into, let me grab my pen again. So it's going to be 2 times 1, 3 times 5. This is 2 over 15. And as always, after multiplying, adding, whatever you're doing with fractions, see if you can reduce them or simplify them. Can we reduce 2 over 15? In other words, is there a number that goes into 2 and 15 at the same time? Is there a common number or a common factor, as we saw earlier? So if you break this down, we can break down the 2. It's a prime factor. It's just 2 times itself, or times 1. I mean, 2 times 1. That's the best you can do with 2. You can't break it down. But we can break down 15 into 5 times 3. So we factored this, we factored this. Nothing is common here, as you can see. Nothing cancels out. Okay, that's how we know the fraction is already simplified. This is the simplest form. So you take this as an answer. Okay, but if you end up with a common factor here or more, you cancel those out to simplify, as we saw earlier. So always reduce your fractions when possible. So the rule here is, in general, when you have any fraction a times any fraction a over b times some fraction c over d, c over d actually. Still getting used to this new pen. It's a stylus pen or an electronic pen I'm using with this tablet. So it's still a little bit hard to move around. So in general, again, remember to just straight multiply. So we say a times c is ac, b times d is bd. Okay, that's the rule for multiplying fractions. Straight across, again, don't think about cross multiplying. We're not going to do that. There's something important here with fractions. When multiplying them, first you want to reduce them as much as possible. If they're not reduced, if you have large fractions here, you don't want to start multiplying right away. You're going to end up with some large number and you still have to simplify it. But if you reduce your fractions before multiplying, you wouldn't have to simplify like here. See, these already reduced, as you can see, simple numbers. We didn't have to do anything here to reduce them. We get the simplest answer. But sometimes, let's say, we may have someone like this. Let's say 1535. You want to multiply that by, let's say, actually, let's see. We can do. I'm going to use 8 here. If you look at these two fractions, again, it's a multiplication. We could multiply right away, but it's much, much convenient and easier to actually try to reduce these as much as possible before multiplying. So to simplify, there's two ways you can simplify. Start with each fraction itself. See if we can reduce it by itself on its own. If you can't reduce each fraction on its own, then you try to simplify these two here, this way. It's what we call cross-simplifying, not cross-multiplying, cross-simplifying. If this doesn't work, if you can't simplify each one by itself, as you can see, 15 and 8, nothing goes into both. Nothing goes into both. Same thing here, nothing common here. Then I'm going to attempt to simplify this way. Can we simplify 15 and 35? If so, what numbers goes into both? 15 and 35. Number goes into, say it again?
5.
5. So we can reduce both of these by 5. 5 into 15, how many times? 5 into 15?
3. I'm sorry, sir.
That's right, 3 times. And then
7.
5, 7. Very good. Now let's say we can reduce these two. So we're going to try to find the highest. What is it? Say it again.
8.
That's right. So 8 goes into both. You want to find the highest one that goes into both, not just 2. 2 goes into both, 4 goes into both, but you want to go with the highest. That way you get the simplest fraction possible. So 8 into 8 once. 8 into 16, how many times?
2.
2. Very good. So now we have much smaller numbers. 3, 2, 1, 7. Something like this. So it's much easier to times those now instead of multiplying large numbers. So it's going to be 3 times 2 over 1 times 7, which is of course 6 over 7. As you can see here, no need to reduce this fraction. It's already reduced. Why? Because we're reduced in advance. If you don't reduce here, look, you're going to get a large number here, 15 times 16, and then a larger number, 8 times 35. And you will still have to simplify because you have to simplify your final answer anyway. So you better do it now before you waste a lot of time and get some large numbers and waste even more time to reduce them. So that's our final answer. What kind of fraction is this, by the way? What type of fraction? Speaking of proper, improper, what type is it?
Proper.
Say it again, sorry.
Proper.
Proper. That's right. If it's, is it proper? Really?
Yes.
When do we say proper or improper? So proper is when A is less than B, when this one is less than this. What we have now is this. The top is higher, so that's improper. Actually, what am I saying? You're right, actually, you are right. The top is smaller, so this is proper because this is smaller than this. Do we need to convert this into a mixed number? Do we need, or can we turn this into a mixed number? And why, if so?
We can turn it into a mixed number.
We can't. Why
Can't.
is that? That's right. Why not?
Because
Could we do 6 but not 7?
Exactly, because it's proper, because 7 does not go into 6. 7 goes 0 times into 6. In other words, you can just say 6. You can just say this, basically. 0 the whole part, and 6 over 7. So we ignore that 0. So that's the reason why we don't turn proper fractions into mixed numbers, because the numerator does not go into the denominator. But if you have something like this, you can definitely turn it into this, because this goes into this twice, not 0 times. Okay, so always reduce your fractions. Again, it makes it a lot easier to reduce first before multiplying. Let's mix things up a little bit. Let's say you have times 4 by, let's say, 1 and maybe 1 times 4 by 1 and 3/8. We have two different numbers here. We have a whole number. We have a mixed number. Obviously, we need to do something about them first before we can multiply. What do you think happens to them first before you multiply them? What do we need to do to these numbers?
first you need to take that mixed number and make it improper.
That's part of it. That's right. So let's turn this one into a fraction. How do you turn this into a fraction again?
You multiply 8 times 1.
That's right. 1 times 8 plus 3. That's the denominator stays the same as 8. Turn this into a fraction. What do we do with the 4?
You bring 4 over and then put it 4 over 1.
Exactly. It also has to be a fraction. So now they're of the same type. These are different types. Now they're of the same type. Any number can be turned into a fraction. Just put a 1 underneath that number. And if you have a mixed number, you can turn it into a fraction. And you can go ahead and multiply straight across. But again, what you need to do before multiplying, you try to do what?
You gotta make
Simplify the fraction.
Exactly. Simplify the fraction. Simplify this way, that way. If not, try this way or that way. Obviously here, nothing cancels out 11 and 1. It's already simplified. What about 4 and 8? Can we reduce that by a number?
So
2, or even better? 2 or what's that? 4. 4 is better. So you want to find the largest number that goes into both. So 4 goes into 4. How many times?
once.
One time, that's right, once. And 4 into 8, twice. So it's easier now to just times those numbers. And it's going to be 1 times 11. And 1 times 2. And again, you will not have to reduce this afterwards because it's already reduced here. It's already reduced. It's going to be 11 over 2. And what kind of fraction is it?
Improper.
Exactly, improper. We can turn it into what type of number we can turn it into? Into a mixed number, right? What is that mixed number? 11 over 2. What is the mixed numbers of this? Okay, do the division. Do what do you have to do? 11 over 2. What is it equal to as a mixed number? Give me the whole part first. In other words, how many times does 2 go into 11?
12.
5 times. That's right. And what's the denominator here? It will be 2. And the remainder,
1.
exactly, that's 1. And that's the final answer here. It's 5 and 1/2. Okay, so if you see different types of numbers, make them the same. With fractions and mixed numbers, usually you will have to turn them both into fractions as we did. Always simplify first. Always, always. It's very important that you do that first. So simplify. Okay, so it kind of makes life a lot easier when you simplify first. Almost done here. We just need to look at the division. So we did the multiplication. This is basically the multiplication. Now, let's see how to divide division of fractions. So to divide these numbers. Start with a simple example here. Let's say you have 4 over 3 divided by 2, or whatever. Let's say 5 over 2. That's an example. Now, this is for multiplication. We multiply it straight across. Now we're going to be careful. This is a division. How do you think we divide fractions? Any ideas on how to divide fractions?
Don't you have to change it into multiplication?
Exactly. Okay, so instead of thinking about cross multiplying, do not use that. Think about turning this into a multiplication. So we can turn this division into a multiplication. At the same time, we need to flip the second one. Only the second one, not this one. So we're going to keep this the same. This turns into a multiplication, and this flips, turns into 2 over 5. So once you do that, now everything we've seen here applies to this. After you turn division into multiplication, then you repeat the same process. We can go ahead and multiply it right away, but again, try to simplify. Nothing simplifies here, nothing simplifies here. We can just multiply these two. That's 8 over 15. It's a proper fraction, can't reduce, nothing goes into 18 and 5, and that's basically your answer. Okay, so 18 over 5. So division is just one step more compared to multiplication. Just want to turn that division into a multiplication and repeat the same process. Let's do, let's say 2 and actually. So another example. Let's say I want to divide maybe 1 2/3, want to divide that by 2 1/6. Okay, so we have division between what types of numbers are these again? Everybody, are you guys over there? Maricela, Gavin, Troy. What type of numbers are these?
What did you say, sir?
What type of numbers are these?
These are both mixed numbers.
Exactly. So we want to divide them, but
to make them improper.
Exactly. So we're going to turn these into fractions first. Once we turn them into fractions like these, then we repeat the same process as here, and there's the division. Let's
Yes,
turn
sir.
this. Turn that. So how do you turn this mixed number into a fraction? You can always start with the denominator.
5 over 3.
That's right. 1 times 3 plus 2, that's 5. It's
Oh,
13 over 6.
divided by 13 over 6.
exactly 2 times 6, 11 plus 1, 13 over 6.
Then we're going to reciprocal.
Right? We're not flipping anything yet. So the first step is to convert. We didn't have anything yet.
It's going to be 5 over 3 times 6 over 13.
Exactly. So now we're going to do the same thing as here. So we're going to do 5 over 13 multiply. To convert this into, or change it into a multiplication. What happens the second one?
Flip it.
Exactly. We're going to flip that second fraction. So this will be 13. Okay, so here we did what we call, so write it down, keep, change, flip, or sometimes we refer to it as KCF. And so this one was one step more than this, and this one also was one more step than here. So this is probably the longest one since it involves converting first. Convert, and then at this point, we did keep, change, flip.
Then your final answer, 3 over 13.
Probably. You change, flip. At this point. Now the final step is to, so before you could just multiply right away, but before that we could simplify it, right? Nothing goes into 5 and 13. Can we reduce these two? Can we reduce 3 and 6? Or
Yes, 2.
what goes into both? 3, right? 3 into 3 once, 3 into 6 twice. Now you can multiply what's left. So we have 5 times 2. It's 10 over 13. Is that the answer you said? Was that, who said that? Was it Troy? Did you say that?
I was thinking something else.
Oh, okay.
Said it differently.
All right, so that's 10 over 13. It's proper, can't reduce because we already reduced here. So again, always reduce first. And you get your simplest final answer, which you don't have to reduce. If you feel lazy to reduce here, for example, you want to multiply 15 by 16. First of all, that's going to be a large multiplication. You can end up with large numbers here, and then you have to simplify those. So this saves time. Simplify first. Always simplify your fractions first before multiplying. And that's your final answer here. 10 over 13, which is again proper and simplified. Okay, so that's basically your little introduction to fractions. They're very important again. The concept of them, we're going to be using this for other topics later, for equations and for ratios, for percentages, proportions, and a bunch of other stuff. So make sure you understand this concept clearly. So the rest of it will make more sense and will be easier to deal with. Did you guys have any questions about any of this?
Yes, sir.
Okay, so this is the best time to understand things. Don't wait or ignore things until it's too late to ask, okay? So always ask during the lecture. So the next lecture will be a little different and so on. So make sure you understand this topic before we move on to the next, because things keep going. You may say the topics, it keeps snowballing as we go from one to the other. It gets bigger and bigger. We learn more rules that we apply for the next class. So this was multiplication and division. Next class, we're going to talk about addition and subtraction of fractions, which is a little different. It requires a lot more work, namely the LCD, or the common denominator, as someone mentioned earlier. So remember, you don't need an LCD for multiplication and division. Okay, no LCD for multiplication and division. You just do what we did, simplify first. For addition and subtraction, that's when we need the least common denominator. We're going to talk about that in detail next class. All right, so that does it for today. So we saw what fractions were. We saw what factoring is, just use breaking down numbers. Simplifying fractions is very important. Always do that before you deal with them or after. Sometimes after you get an answer, you need to simplify it. It's part of the answer. You learn how to convert back and forth between improper and mixed numbers. And finally, we'll learn how to multiply and divide fractions. If you want to write the rule here, so we wrote the rule for this straight across, but if it's division, this is what you do. So in general, if you have A over B divided by C over D, first you want to keep change flip. So this turns into A over B times, so the division turns into a multiplication, D over C. Finally, once you do that, you can now multiply straight across because it's a multiplication. So you can say AD and B times C or BC. Okay, that's the rule for division. Any questions, everybody, about any of this?
No.
Okay. All right, so I'll post this video itself. You guys can rewatch it later. And